All right, so now we're ready to take a look at a couple examples in this video. And the first one we'll look at is the inverse cosine of 1 over root 2. Now, it's important to understand why we need these inverse cosine functions so badly. And so if you remember back from algebra, a function takes you somewhere and the inverse takes you back. So in this particular problem, we're not searching for the ratio. Instead, we're searching for the angle. So what I'd recommend on these types of problems is understanding you're looking for an angle. Specifically, we're trying to find theta such that cosine of theta is 1 over root 2. That's the theta we need to find. Now, theta here, this guy, is the answer to inverse cosine. Well, inverse cosine is only allowed to exist in quadrants 1 or 2. Now, moving over to the other statement, and this is important to follow, cosine is positive. That's a positive quantity over there. So cosine is positive. Cosine is positive in quadrants 1 and 4. So the overlapping quadrant there would be quadrant 1, which means that's where our angle in this problem is going to lie, in quadrant 1. So if I draw my triangle in quadrant 1, we can see here cosine is 1 over root 2. So that's going to tell us that that's going to be a 1 and a root 2. That also then has to be a 1 there. And this is one of our special triangles. The angle that sits in here now, based upon the 1, 1, root 2, is going to be pi over 4. So the answer to this is pi over 4. All right, in this one, we actually are given arc sine of negative root 3 over 2. Sometimes depending on the author or the textbook or whatever, the arc sine, arc cosine, arc secant, arc being out in front like it is here, this just also implies the inverse trig function. So you can see those and they're just pretty much the same thing. So for us, we're looking at arc sine of negative root 3 over 2. And as I mentioned before, this means we're looking for an angle. Specifically, we want to find theta such that sine of theta equals negative root 3 over 2. Theta here for inverse sine can only be in quadrants 1 or 4, and sine is negative in quadrants 3 and 4. So the overlap puts us in quadrant 4. So I'll go ahead and I'll draw my triangle in quadrant 4. Seeing as we were given sine equaling negative root 3 over 2, I would need to go ahead and label negative root 3 a 2. That means the top part is a 1. And then, seeing as that's a special triangle, you can see now we're looking at a negative pi over 3. So our theta here is a negative pi over 3. Now, it's important to remember, the negative pi over 3 is the only answer. Some of you might be thinking, and if so, it's not a bad thought initially, that, well, can't I give this angle? That angle is 5 pi over 3, and that's the same thing. Well, not in context. In context, this statement right here comes from the fact that inverse sine has to be between negative pi over 2 and pi over 2. 5 pi over 3 doesn't work there, but negative pi over 3 does. So we got to make sure the answers we give are truly bounded by the restrictions given earlier in the video. All right, the next example is going to be inverse secant of 1. So we'll approach it the same way. We understand we're looking for an angle. Specifically, we're trying to find the angle such that secant of theta equals 1. So for inverse secant, that theta can only be found in quadrants 1 or 2. and secant is positive. Secant is positive in quadrants 1 and 4. So far, kind of the same thought process. That being said, I also know now that if I go drawing my triangle here in quadrant 1, it's not really going to work out too well because at 1, that's not actually a triangle. So as always, if we can't resort to the triangles, we have to go all the way back to the unit circle. And so on the unit circle, we can see that the point that we would really need to be interested in would be this one right here. This is the point 1, 0. And I say that's the point we would be interested in because if you can note here, with secant theta equaling 1, that's the same thing as 1 over cosine theta equaling 1, which says that cosine theta needs to be 1. We know that cosine is the x-coordinate on the unit circle, and so the angle at which cosine of that angle is equal to 1 looks like it has to be right here at 0. So in this case, the answer would be 0. The inverse secant of 1 equals 0. So for the next three examples, we're going to look at some calculator problems. The first one, inverse cosine. You'll notice above the sine, cosine, and tangent buttons on your calculator, you have the inverses of those. So they're probably secondary features. And all you have to do is punch in the 0.7392, hit the inverse cosine command, and it should spit out the answer for you. Now the instructions do say to give angles in radians, so do make sure your calculator's in radian mode. But if you do this correctly, you should get 0.7389. Okay, so hopefully nothing too difficult there. Now, for the other two examples, the inverse cosecant and inverse cotangent, you do not have buttons on your calculator. But that's okay, because we can approach these the same way we did the last few examples. If I understand that I'm looking for an angle, I can find the theta such that cosecant of theta equals 6.8212. Okay, so theta has to be found in either quadrants 1 or 4 for inverse cosecant, and cosecant is positive in quadrants 1 or 2. So it looks like our angle that we're going to be searching for is going to be in quadrant 1. So that's important to remember. We want to make sure our calculators don't lie to us. So to punch this in a calculator, it looks like I'm probably going to have to come down here and view this as 1 over sine of theta equals 6.8212, which says sine of theta equals 1 over 6.8212. So that theta that we're looking for is going to be found by the inverse sine of 1 over 6.8212. So that's a way to get around not having that inverse cosecant button on your calculator. And once you punch this in, it looks like the answer should come up to be 0.1471. All right, so I'll go ahead and I'll put a line down here to separate all this stuff. Also going to go ahead and make sure I copied down the problem correctly. That should be a negative 3.14 inside parentheses. So we'll handle this one the same way. We understand we're looking for theta. We're going to find theta such that cotan of theta equals a negative 3.14. The angle theta for inverse cotan is going to be either quadrants 1 or 2. And then cotangent is negative. Cotangent is negative in quadrants 2 or 4. All right, so we know that we're looking for an angle in quadrant 2. Now, we'll come down here and we'll say that since we don't have a cotangent button on our calculator, that's going to be 1 over tangent equals negative 3.14. Or, in other words, tangent of theta equals 1 over negative 3.14. So to actually be able to punch this in now, theta is going to be the inverse tan of negative 1 over 3.14. So when you punch it in your calculator, you're going to get an output of negative 0.3083. Now, this is where our calculators can lie to us a little bit. That number's not wrong for where we are in the process, but it's not the correct answer to the problem. Remember, up here, we said we needed to be in quadrant 2. Well, when I punch inverse tan in my calculator, it only understands to give outputs in quadrants 1 or 4. Inverse tangent only exists in 1 and 4. So it gave me an answer in quadrant 4. So if I'm in quadrant 4 currently, and I want to be in quadrant 2, then I'll need to take that number and I'll need to add pi radians to it. That's going to then put me in quadrant 2 where I need to be. So if we add the pi to it, that's going to give us a 2.8333 for a final answer. And you can check that in degrees if you need to visualize it that way, or you can also understand that that's pi, which is about 3.14. 2.8 is less than that, so we are going to be in quadrant 2 where we belong.